are the team from Harbin Institute of Technology. Today, we bring the cavity-type solar thermoelectric power generating device. My report is separated into 4 parts as you can see on the PPT. So, first of all, I will start to introduce the development background. As we all know, with the mounting consumption of energy of the entire globe and the increasingly serious environmental problems, the development of new energy is imminent. At present, in the world energy structure, human beings mainly use fossil energy, which consists of 91%, and the other 9% are new energy, of which solar energy is the most important renewable energy because it is clean, pollution-free, and not restricted by the placeholder resources. So, the research and application of solar energy is the main trend. However, in the current utilization of solar energy mainly includes the photothermal conversion and the photoelectricity conversion. So, the highlight of our device is that we can solve the problems of these traditional solar energy devices and can largely improve the application of solar energy. Then, going to the next part, the research process. According to our research, most of the thermoelectric generators are flat plate type, but our device employs the cavity type design, and we set brainstorm lines about it. This design will improve the solar energy absorption rate effectively, and its impact structure make it easy to place and transfer. The core device includes 5 parts. You can see on the picture. And then we will see the flow chart of the operating principle for our device. Next, we will introduce the introduction of our technology. The lines type, our device can be separated into 3 parts: the lines type condenser area, the power generating area, and the cooling area. The lines type condenser area is consisted of Fresnel lines. It's allowing a large area of sunlight within the angle of incidence to be concentrated on a relevantly small area, thus effectively ensuring the condensation and increasing light intensity. Then, when the sun shines through the lens type area, it will arrive at the power generation area. This area is the core part of our device. This part includes 5 sections, as the picture shows. The heat of the sunlight is collected by the solar heat collecting area, which is made by solar panels with multi-pools. Then the heat will be sent to the primary generator area and the secondary generator area. These 2 sections are both made of semiconductor materials because of conductivity. Between these 2 sections are separation device and connecting device. The separation device is used for separating the 2 power generation. Meanwhile, it also used for connecting the semiconductor materials with the copper sheet inside. And then the connecting area was used to connecting device semiconductor material for the secondary generator area. With the help of these 2 parts, the whole device forms a return circuit. At the same time, the cooling area keeps the bottom of our device at a low level, so that the whole device can form a return circuit. So we can form the temperature difference, and this temperature difference will provide electricity. And the figure 6 is the heat distribution when the device is working, and the figure 7 is the cooling area. It's a water cooling system. Finally, through calculation, we got that the conversion efficiency is 6.23, which is much higher than most of the flat plate tap ones. At last, as you mentioned the application prospect. This device is energy-saving, environmental-friendly, low in cost, and stable in operation, which ensure it will be prospective for application. As you can see, it can be applied to various fields. For example, it can be set on the roof of high-speed rail to provide electricity for passengers, so it can reduce electricity from power grid. As we all know, the high-speed rail in China is advanced and popular, so the market is huge. Then it can also be used in the aviation fields, like solar cell. Replacing the flat plate tap ones, the volume of the solar cell will shrink, the weight will fall, and the cost will naturally reduce. What's more, it can also be used on the car or even on the mobile phone, which means it will be particularly widely used in our daily life. And this is the award we won, and our patent right is in auditing. So that's all for my report. Thank you for listening.
How you use solar energy to create electricity? How does it compare to the usual way, photovoltaic?
We use the temperature difference because of the semiconductor materials. If there is temperature difference, the whole device will provide electricity.
I'm talking about economical wise. How does it compare? Per kilowatt, how much does it cost? Comparing this to the usual PV.
Because of our device is a cavity type, and the Euro type is flat plate type. We set facial length about the whole device, and the facial length can improve the my partner will answer a question.
Well, our device cost is very cheap, and to the ordinary ones, we change its shape, and it can collect more light and have more heat. So the temperature device will be large, and the efficiency is very high. The normal solar cells and its efficiency is about 4%, and our device it can reach 6.2%. Like this.
Yeah, I think that's where the question is about, because the photovoltaic currently is easily 18% instead of 4% that you mentioned. So if you compare your system using the solar energy, then actually the 6.23% is much lower than the photovoltaic. So you must be able to use the wasted heat, which I think is where the thermoelectrics come into play.
Well, it can use to collect the waste heat to get the electricity, and if we get a Fresnel lens on it, and it can collect the sunlight. So I think it's both solar and waste heat. It can use this heat, either the solar heat or the waste heat. Yeah.
So you should design a system by combining that photovoltaic with your thermoelectric, So the photovoltaic will actually convert the solar energy quite effectively, and there still be a waste heat from PV cell. Then you can use that waste heat to do this thermoelectric conversion.
All right, that's a good advice. Thank you.
Probably may improve the thermal materials. Now, what material you use for your system?
We use semiconductor materials, just like PBTE. I don't know the words. It's a semiconductor materials. And that's all for my answer.
Okay, it's time. Thank you.
谢谢。
好，针对委员的提问，我们特别解释一下。
Our device, these two models is our, these two is our two models, and when the sensor throw the last time error, it will arrive at the core device of the core of our device. The power generation error, and the heat will be collected. Then the heat will be sent to the primary generator and the secondary generator. Both of the two generators are made of semiconductor materials. Because of the conductivity between the two sections are separation device and the connecting device. The separation device is used for separating the two generators with a shift coupler inside and connecting the two generators. The secondary generator is the connecting device used for connecting the second semiconductor materials of the secondary generator, and then they will form the return circuit. At the same time, the cooling system will keep the temperature of the bottom of the semiconductor materials of the secondary generator at a low level. Then there forms the temperature difference. With the help of the temperature difference, it will provide electricity just like this. It can provide 5 volts.
So you have a solar cell in it.
Yeah.
But you don't have a light source now. Doesn't that source good enough?
No, we have sent.
So you don't have the
heat to the tower.
Yeah, but how could you charge this without the light source? We have generated power.
We have some battery.
You have a battery inside?
Yeah.
Oh, okay. So that's the battery stored.
When the light isn't enough, the battery will provide electricity inside of the device.
Over here, you have the thermal electricity here.
This one is a model to show the structure.
Oh, it's only a model.
Yeah. Show the structure inside. Just like this. Inside it will like this.
Okay. What am I looking at? Is there a solar cell?
No.
The wires there?
No. Inside is not a cell. It's to collect the heat of the solar.
So the two different poles here are two different materials?
No, they are the same material.
Well, according to your chart, it seems like that's where you generate.
This is the cold side and the pole side.
Different temperature.
They have the different temperature.
Then actually it's like a concentrated solar power.
Yes, it's not photo electric. It's thermoelectric.